Let me explain Reynolds number. Imagine two teams playing tug of war, inertia versus viscosity. Let's understand each team separately. Inertia. Inertia is nothing but the fluid's desire to keep moving. The faster the fluid moves, the stronger the inertia becomes. So, inertia increases as the momentum of the fluid increases. And viscosity, on the other hand, is the fluid's internal resistance to this movement. So, it is like internal friction of the fluid, and its job is to calm down the fluid. So, whenever tiny disturbances appear, viscosity tries to smooth them out. That is the difference between inertia and viscosity. Now, what happens if in this game, the tug of war, what happens if inertia pulls harder? Tiny disturbances begin growing and the layers start mixing, because we've seen that inertia only appears when there is a lot of movement, right? So, because of that, tiny whirlpools appear and the entire flow becomes chaotic. And this chaotic flow is termed as turbulent flow. So, if inertia pulls harder, it becomes turbulent flow. And on the other hand, if viscosity pulls harder, the fluid stays calm and it moves smoothly. There's no mixing, and the flow is smooth. You can't even observe that the fluid is moving. The flow is that smooth. So this flow is termed as laminar flow. Now, if we need to understand which team is winning, is it the inertia or the viscosity, we need to understand one simple number, which is Reynolds number. But what is Reynolds number? So it is the ratio of inertia forces and viscous forces. So Reynolds number has a formula rho VL by mu. Everything in the numerator, if you see, the density, velocity, characteristic length, all of these, they make inertia stronger. So if the numerator increases, the inertia increases and the fluid's flow becomes turbulent. On the other hand, in the denominator, we have mu, which is the viscosity. And if viscosity increases, the flow becomes smooth and it's going to go towards laminar flow. So if the numerator is going to increase, the flow is going to become turbulent, and if denominator increases, the flow is going to become laminar. Inside a circular pipe, Reynolds number, if it is less than 2300, the flow can be classified as laminar flow or a smooth flow. And if it is in between 2300 to 4000, the Reynolds number, then it is transition. What transition means is that a region where flow may switch between laminar and turbulent. So that is transition region. And if the Reynolds number is more than 4000, it is going to be turbulent flow. So this is for a flow inside a circular pipe. Let's go through the checklist. So inertia forces, we understood what inertia forces are. Nothing but fluid wants to keep moving if it has stronger inertia, and the fluid wants to stay calm if the viscous forces are more. So if inertia forces are more, it is going to be turbulent flow, and if viscous forces are strong, it's going to be laminar flow, which is smooth flow, and turbulent flow is nothing but um, chaotic flow. And finally, the Reynolds number would be rho VL by mu, where the numerator consists of inertia forces and the denominator consists of the viscous forces. That is Reynolds number. It simply determines whether the flow is going to be turbulent or is it going to be laminar. Thank you.